Hi there, we're going to calculate the determinant of this 3 by 3 matrix. Notice the determinant is denoted by these straight lines on the side. I've written the formula for a 3 by 3 determinant here in black, but you really shouldn't memorize that. Instead, you should memorize the pattern that we use to create it. And I hope going through this example will help you remember what that pattern is. Setting up the 3 by 3 determinant is as easy as this. First, we need to take the first row of our matrix. So we'll have 3, 2, and -1. And what are these numbers doing? Well, they're each going to get multiplied by a 2 by 2 determinant. So this is 3 times the determinant of a 2 by 2 matrix. We'll worry about that specific matrix in a second. But similarly, we're going to have 2 multiplied by a determinant of a 2 by 2 matrix, and -1 multiplied by a determinant of a 2 by 2 matrix. Then you should ask, what's actually happening between these three things? Are they getting multiplied or added or subtracted? Well, it's actually alternating. So first we have plus, meaning this first thing should be added. Then we have minus, so this second thing should be subtracted, and then we have plus, so the third thing should be added. And this is always how it works. It doesn't depend on the specific 3 by 3 matrix. It's always plus, minus, plus. Finally, like I said, these things are 2 by 2 determinants. But what matrices are we actually taking the determinants of? Let's start with this one, 3 times the determinant. 3 is the first entry of our matrix. You should imagine blocking out that whole first row and that whole first column. The sub-matrix that remains is the matrix that we're taking the determinant of. So that's 6, 7, 1, and -3. And it works similarly for these other terms. So we have minus 2 times the determinant of a matrix. What matrix? Well, 2 is coming from the second column of our matrix. So imagine blocking out that whole row and that whole column. The submatrix that remains with those 4 entries is the matrix that we're taking the determinant of. So 4, 7, 2, and -3. Finally, for the third term here, we've got -1 times the determinant of a 2 by 2 matrix. So imagine blocking off the row that has -1 and the column that has -1. The submatrix that remains is the one that we're taking the determinant of. So if you can remember that pattern and you know how to find 2 by 2 determinants, then you can find 3 by 3 determinants. So let's finish this problem off. We've got 3 multiplied by this 2 by 2 determinant. To find the 2 by 2 determinant, we take 6 times -3, which is -18, minus 1 times 7, which is 7. And then we subtract 2 times this determinant, which is 4 times -3, which is -12, minus 2 times 7, which is 14. And then we add -1 times this determinant, which is 4 times 1, which is 4, minus 2 times 6, which is 12. Now all that stands in our way is some arithmetic. -18 minus 7 is -25, and then -12 minus 14 is -26. And then finally, 4 minus 12 is -8. So finishing this up, 3 times -25 is -75. -2 times -26 is +52. And -1 times -8 is +8. And this comes out to -15. So that is the determinant of the 3 by 3 matrix. That's how we calculate it. Hopefully you found that helpful. Focus on the pattern that we used to construct this expression. Go ahead and try it yourself on this example. Find the determinant of this 3 by 3 matrix. I'll put the final answer in the description, but here is how you would set up the calculation. Notice how we begin with the first 3 entries from our matrix. We have plus, minus, plus, and then we imagine blocking these things off to get the sub-matrices that we're taking determinants of. Hope this was helpful. Let me know how the question went in the comments and if you've got any questions.
Rather be out of the way, 'cause I don't wanna hear what the people say. I've heard it before, it's such a